Section 2.6 is all about rational functions. Before we get into the actual functions, let's talk about asymptotes to start. So definitions for vertical and horizontal asymptotes. The line x equals a is a vertical asymptote of the graph of f if f of x approaches either infinity, so it's either going up, or f of x approaches negative infinity as x approaches a. So like that means it's as like x is approaching the a from the right side, so like maybe it's going from left to right, or is it going from left or right to left, so both directions. The line y equals b is a horizontal asymptote if f of x approaches b, so like if it's getting further and further and further, as your x value is approaching negative infinity or positive infinity. So this is going further and further to the right or to the left, it's getting closer and closer to this horizontal line. So taking a look at this example here, this specific example has a vertical asymptote. So it's got a vertical asymptote at the line x equals 0. This function, by the way, I should have clarified, is f of x equals 1 over x. Now the horizontal asymptote, in this case, is the line y equals 0. So as the graph goes further and further to the right and to the left, it's getting closer and closer to x equals 0. Or sorry, y equals 0. So with that information, we're going to talk about the vertical and horizontal asymptotes of rational functions. So let some function f be the rational function as defined by this. N of x over d of x. So n of x for numerator, d of x for denominator. The numerator is going to be some a sub n times x to the nth. It's really just some degree n polynomial. And then d of x is going to be some degree m polynomial. And they've got no common factor, so we can't reduce it anymore. The graph has vertical asymptotes for the zeros of d of x. In other words, the zeros of your denominator. So whatever makes your denominator equal to 0 is going to be a vertical asymptote. Now the graph of f has one or no horizontal asymptotes determined by comparing the degrees of them. So the degree of the numerator is n, the degree of the denominator is m. So if n is less than m, then the graph has the line y equals 0 as its horizontal asymptote. If the degrees are equal to each other, n is equal to m, then the graph of f has the line y equals a sub n over a sub m. In other words, b sub m. In other words, the ratio of the leading coefficients, and that's a horizontal asymptote. Now, if the degree of the numerator is greater than the degree of the denominator, then it's got no horizontal asymptote. We're going to come back and reference these in a little bit. And by a little bit, I mean on these next examples. So we're asked to find all vertical and horizontal asymptotes of the graph of the rational functions. So the first one, we got f of x equals 2x squared. So 2x squared over x squared minus 1. Now, before we go any further, I'm just going to identify the degree of the numerator and denominator. The degree of the numerator is 2. The degree of the denominator is also 2. So the vertical asymptote, it's whatever makes your denominator equal to 0. So we're going to set x squared minus 1 equals 0. To solve for x, we're going to add 1 to both sides. We get x squared equals 1. And to solve for x, we're going to have this take the square root of both sides. And we end up with x equals plus or minus 1. There are 2 vertical asymptotes for this graph. Now, if it helps you to think about it this way, you could factor out the x squared minus 1 into x plus 1 times x minus 1. Either way you do it, you're going to end up with x equals negative 1 and x equals positive 1. So this has 2 vertical asymptotes. Now for the horizontal asymptote, this one again, we got to look at the degrees. Since the degree of the numerator is equal to the degree of the denominator, what we're going to do is we're going to do the ratio of the leading coefficients. So it's going to be y equals leading coefficient of the numerator, 2, divided by the leading coefficient of the denominator, 1. So in other words, it's the horizontal line y equals 2. Now we can take a look at this on a graphing calculator. Let me show you what that would look like. So I'm going to do this on the calculator here and show you on the camera. So if I graph, clear that out. Let's see, 2x squared divided by x squared minus 1. Let me make sure I've got that in parentheses. Oops. So just showing what I typed in. We got there we go. 2x squared divided by x squared minus 1. And if we graph this, we will see those asymptotes at 1 and at negative 1. So if we were to draw a vertical line at negative 1 at positive 1, we'd have an asymptote there. And also the line y equals 2, that horizontal line, it's never going to quite get there. Letter B is f of x equals x squared plus x minus 2 over x squared minus x minus 6. Starting off again, let's just identify the degree. So the degree of the numerator is 2. The degree of the denominator is also 2. Now, in order for us to be able to do the processes that we talked about on the previous page, we got to make sure there aren't any common factors. So in order to determine that there aren't any common factors, we're actually going to have to factor this out a little bit. So f of x equals that numerator x squared plus x minus 2. If we can think of two numbers that multiply to negative 2 and add to positive 1 for that positive 1x, we'll be able to factor it. And we can do x plus 2, x minus 1. Now for the denominator, x squared minus x minus 6, we can break that down into x plus 2 times x minus 3, which is going to reduce nicely, leaving us with just x minus 1 over x minus 3. So now our vertical asymptote is whatever makes the denominator equal to 0. So we have x minus 3 equals 0. So if we add 3 to both sides, we get the vertical asymptote of x equals 3. For our horizontal asymptote, again, the numerator and denominator have the same degree, so n equals m. Therefore, it's y equals the leading coefficient in the numerator, 1, divided by the leading coefficient of the denominator, also 1. In other words, y equals 1. So we have a vertical asymptote of the line x equals 3, the horizontal asymptote of y equals 1.